So you might take physics. Physics is the science of engineers. It's a physical and mathematical description of the world around us. Engineers take physics, architects take physics, doctors take physics, nurses take physics, physical therapists take physics. All these things, lawyers, patent lawyers especially, will take physics. A physics class on your transcript helps you get into college. Now we start off easy. These are the equations that describe motion. Here's a car moving at a constant speed in front of the school. This is a little more complicated, right? This is an object flying through space, and we're predicting exactly where it'll land and what its velocity is. This, of course, leads to ill-advised teacher demonstrations. What you can't see is that there's a little ball that's going to fly out of this cart, and bets have been made. This is the Air Rocket Lab. With the Air Rocket Lab, we measure how long they stay in the air, what time they stay in the air. With the time, we can figure out the velocity. With the velocity, we can predict exactly where they'll land, which leads to the rocket target competition. Not all the labs are super exciting like that. Here he's marking where dots are on a tape. This is electrostatics, so Physics 2 will cover electrostatics and magnetism. This is a magnetically driven hard drive seek arm going across the disk. Look how fast this thing moves. This is amazing. So this is what we study in Physics 2. This is a Physics 2 research project. You will actually become a rocket scientist in this class.
9, 8, 7, 6.
You always launch it at 6, right?
Whoa! What's going on? Oh, no!
Here's another momentum demonstration. Now, not everything goes the way you think it's going to go in a demonstration.
Fire a wheel, Commander. On your mark.
Yeah, now we back away.
Unfortunately, we set the target box on fire. This is my student teacher from years ago. And those balloons are full of...
above average.
Those balloons were full of stoichiometric quantity of hydrogen and oxygen. At the end of the year, we're gonna study waves. Waves set up. These are standing waves in a pipe, and the standing waves in a pipe are the basis of music and harmony. We can visualize these on a pipe with, again, with flame. This is called a Rubens tube. And I'm just singing into that pipe, and you can visualize the waves on that pipe. This is a laser light show that does the same thing, just in a different way. For some reason, country western songs draw the best laser pictures. Of course, there's Oaks Park at the end of the year. At Oaks Park, we actually gather data from these rides. These rides generate G-forces. This is Adrenaline Peak. It's the new roller coaster. But for example, the Ferris wheel actually generates a G-force. You can measure it. This is measured with an accelerometer. This is the Rocco plane, a somewhat more violent ride. And we can predict this data using physics formulas. At the end of the year, we do a physics demo night called the Extravaganza, where students present demonstrations. Here's that flame pipe again, this time with an electric guitar driving it. This is at Tigard High School, too. It seems like we're going to be doing them at 12. This guy took the laser out of a Blu-ray player and is lighting matches with it. Just look out, man. This is cornstarch and water, which is a non-Newtonian fluid. When you shake it, it makes these strange little things that come out. This is a magnet floating on a superconductor. That boiling stuff is actually liquid nitrogen. Liquid nitrogen can be used to freeze flowers. And these are our harmonographs. They draw really cool pictures. Following the extravaganza, there is a show by Rhys Thomas, who's an amazing juggler who does a science show. One thing you should also know about physics is that it's not a traditional classroom. In a traditional classroom, the teacher shows you stuff in class. You go home and do homework at home. In a flipped classroom, we do the lecture-y stuff at home. You watch videos at home. and we do labs and demos and homework at school. And it's very much web-based. So if you look at one of the pages on the website, this is the one for Force. We've got the syllabus handouts. We've got lectures. We've got a website that shows you how to do the labs. These show you how to do all of the assessments, all the tests. And here's all the content. So here's a note guide. You could download that, and you can take notes on this particular video. I hope that helps you make your decision.